wheels of my suitcase are broken. What angle should I pull the suitcase so that I apply minimal effort? Let's see. So let us first look at the free body diagram. This is my Spider-Man suitcase of mass m, hence it will have a weight of mg. This is the normal force. This is the force that I am applying to the suitcase at an angle of theta with the horizontal so that it moves with a constant velocity. As the suitcase is moving in this direction, there will be a frictional force which is in the opposite direction, which has a kinetic frictional coefficient mu. As my force that I am applying is a vector, it can be further split into two components, one horizontal component and one vertical component. Okay, so now let me write the equations. So as the velocity is constant, the acceleration will be 0, which means that the sum of all forces in the x direction should be 0. That means that the horizontal component of my force that I am applying, F cosine theta, minus the frictional force which is in the opposite direction and will be negative because I have chosen this direction positive, minus the frictional force is equal to 0. Now we can also write the frictional force as mu n. Therefore, this equation becomes F cosine theta minus mu n is equal to 0. Therefore, this is F cosine theta is equal to mu n, or n is equal to F cosine theta divided by mu. So now we can do the same for y direction. The summation of all forces in the y direction will also be equal to 0. That means the normal force plus the vertical component of the force that I am applying, F sine theta, minus mg, because this is the weight is in the negative direction and I have chosen this as the positive direction. So minus mg should be equal to 0. Now I can substitute this value of n here. So F cosine theta divided by mu plus F sine theta minus mg is equal to 0. Now I can make the denominator common as mu. So F cosine theta plus mu times F sine theta minus mu times mg divided by mu is equal to 0. I can also factor out an f from here. So f cosine theta plus mu sine theta is minus mu mg by mu is equal to 0. So now mu cannot be 0, otherwise this becomes undefined. Therefore I can eliminate this part. So now the main idea is to separate my force F. So F multiplied by cos theta plus mu sine theta is equal to mu mg, which means that the force that I am applying to the suitcase is equal to mu mg divided by cosine theta plus mu sine theta. So now as you can see, the force is dependent on the mass m of the suitcase. The larger the weight, the more force I have to apply. It is also proportional to the frictional coefficient mu and the angle theta. So as the weight of my suitcase and mu are constant, so let me differentiate my force with respect to the angle theta. So d by d theta of F is equal to d by d theta of mu mg multiplied by cosine theta plus mu sine theta raised to negative 1 The mu mg is a constant, so it comes outside. This is equal to mu mg d by d theta of cosine theta plus mu sine theta raised to -1. Now we can use a little bit of a power rule and as well as the chain rule. This is equal to mu mg multiplied by -1 multiplied by cosine theta plus mu sine theta raised to -2 multiplied by minus sine theta plus mu cosine theta. Now we can also write this as minus mu mg multiplied by minus sine theta plus mu cosine theta divided by cosine theta plus mu sine theta squared. Now this can also be equated to 0. Now the denominator can be 0, otherwise this will be undefined. Mu mg cannot be 0 because that is a constant. So this term has to be 0. We can equate it to 0. Minus sine theta plus mu cosine theta is equal to 0. That means sine theta is equal to mu cosine theta, or mu is equal to tan theta, which also means that theta is equal to tan inverse of mu. So as you can see, the angle at which I pull the suitcase is directly proportional to the frictional coefficient. So for example, if the kinetic frictional coefficient mu was 1, I would have to pull the suitcase at an angle of 45 degrees to minimize my effort. Let's say now the surface was rougher and mu was 1.7. Then I would have to pull the suitcase at an angle of 60 degrees. Oh, by the way, where is my suitcase? I guess someone has already dragged it.